So the big picture for this lesson is reflections and perpendicular lines. A reflection is an example of rigid motion. That means an object moves but it doesn't change size or shape. So there are two parts to reflection. There's the pre-image, which is the image before the reflection. That's this guy over here. And then there's the image, which is after the transformation or after the reflection. That goes here. And the line L, that's the line of reflection. Then there's perpendicular lines. Now perpendicular lines form right angles. And a perpendicular bisector divides a segment in half. So you can see here that line L is the perpendicular bisector of segment AB, and M is the midpoint. So the reason we're talking about perpendicular bisectors in this reflection lesson is because that's the definition of a reflection. A reflection maps a point to its image through a line, and that line is the perpendicular bisector of the segment that connects them. So in other words, point B to point B prime, the line S is a perpendicular bisector. And the same is true with every single pair of points between the image and the pre-image. Line S is the perpendicular bisector for the segment that connects those 2 points. And there are special patterns for certain types of reflections. For example, a y-axis reflection, any point xy maps to negative xy. So you just make the x value negative, the y value stays the same. Over the x-axis, the x value stays the same, but the y value becomes negative. And over the line y equals x, you switch the x and y values. So you're going to be practicing reflecting points, and you're also going to be writing and solving equations based on reflections, and you're going to practice the construction of a perpendicular bisector. And that's the big picture.